In today's lecture, we will see what the product rule and the quotient rule of differentiation is. The product rule. If there is a function which is a product of two functions, that is gx and hx, then the differentiation of that function becomes gx, that means the first function, multiplied by the differentiation of the second function, that is h slash x, plus multiplication of the second function into the differentiation of the first function. So that is the rule for the product of two functions. Let's see what the quotient rule or the division rule of two functions means. So if there is a function fx which is a division of two functions, that is gx and hx, that means if fx equal to gx divided by hx, this is the numerator, this is the denominator. Okay, so the rule says that the differentiation of this function fx is equal to the denominator function multiplied by the differentiation of the numerator function minus the numerator multiplied by the differentiation of the denominator upon the denominator squared. Okay, let's see some examples to make these two rules clear. Let's say fx is equal to 5 let's say x squared plus 2 multiplied by 3x plus x cubed. So f dash x, so this is the first function, this is the second function. So we will take the first function as it is. So it is the first function, it means x squared plus 2 multiplied by the differentiation of the second function. Differentiation of this function, differentiation of 3x gives us 3, and differentiation of x cubed gives us 3x squared. Okay, now plus the second function multiplied by the differential of the first function. What is the differential of the first function? X squared. Differential of x squared is 2x, and the differentiation of 2 is 0. So it's only 2x. Now we just have to expand this expression, or we can see if we can simplify this. So this is 3 into 1 plus x squared plus, let's say we take out x here. So x into x becomes 2x squared to 2x squared into 3 plus x squared. Okay. So this becomes, is there anything common here? There's nothing common here. So it's better to just expand the expression as it is. So it is 3 into, let's multiply this by this, is x squared plus 1 into x squared plus 2. That means x squared plus 2 plus x squared plus 1. That means x squared is x squared plus, this is x squared. Okay, let's see this one. This is x squared, and this is x to the power 4 plus this is 2 plus 2x squared. Okay, and the other one is 6x squared plus 2x to the power 4. So ultimately we'll get, this is x squared, the x squared plus x squared is 3x squared. So now we get 3x to the power 4 plus 9x squared plus 6 plus 6x squared plus 2x to the power 4, which gives us 5x to the power 4 plus 15x squared plus 6. Okay. So this is how you solve a problem on product of two functions. Now let's take a function where fx is equal to x squared minus 2 and x plus 4, where x is not equal to minus 4, because at x equal to minus 4, this function, this whole expression becomes indeterminate. Okay, so except at x to the not equal to minus 4, this function is a continuous function. So let's see this one. So f dash x is equal to, we have the denominator x plus 4 multiplied by the differential of the numerator, that is 2x minus 0. So it is 2x minus x squared minus 2, that is the numerator, into the differential of the numerator, that is differential of x is 1 and differential of 4 is 0. So it is only 1 upon the denominator whole squared. Okay, so you just have to resolve this one. 2x squared, this is 2x squared plus 8x minus x squared plus 2. So upon x plus 4 whole squared. So we get 2x squared minus x squared is x squared plus 8x plus 2 upon x plus 4 squared. If it is possible again to factorize this expression to simplify this, otherwise we leave the expression as it is. Okay, so this is how you solve problems on product rule and quotient rule. Thanks for watching. Until we meet in the next lecture.